Welcome to Chapter 4. We'll be covering fluid, smoke, and fire physics in this chapter. Let's go ahead and dive right in. Fluid physics are super fun to create in Blender, and there's many easy ways to do so. The easiest way is to click on your object, go to our object menu. We're going to go down here to Quick Effects, and then we're going to find something called Quick Liquid. We're going to click on that. All right, and right away we kind of see there's a lot going on here. We have this cube that's already outlined, a cube within our cube, and then a smaller cube within our bigger cube. I'm going to go back to frame 1 here. I'm going to go ahead and press play. And you'll see just like that, we have a liquid simulation, which is really cool. But there's a lot that I need to go over. I'm going to actually delete everything. That's a really quick way to add a physics simulation with fluid. But I want to show you the manual way so that you understand every aspect of what we need to do. I'm going to switch back to my solid mode here. All right, now in my solid mode, I have a cube. All right, I need 2 cubes. All right, one of these cubes is going to be our fluid flow, and the other cube is going to be our domain. The best way to think about our domain is the domain is where the physics simulation takes place. So on our right-hand side, I'm going to add a fluid physics property to our domain. I'm also going to call this domain. I'm going to double click in our hierarchy. I'm going to name this domain. And then you can see right here it says fluid. The type, we're going to click on domain. And now we have our domain. Switch the domain type to liquid, okay? And now you're not really going to notice anything. There's a really big menu over here, and I will go over all of this in a second. But before we do that, I want to switch over to my X-ray mode here. I want to go to my side view, and I'm going to scale up my domain and make sure that is right around our other cube. Now our cube within this domain is going to be our fluid flow. This is what the fluid is going to come out of. Think of a sink faucet or something like that, or a hose in your backyard that water comes out of. Now there's many ways to make the water come out of this, but I'm going to first start by adding a fluid property. I'm going to click type. I'm going to go to flow, and then you'll see right here we have more options. For the flow type, I'm going to, of course, select liquid. And then we have a couple of different options here. We have geometry, inflow, and outflow. Geometry would be like if you had a cube of liquid that you just dropped on the floor, okay? As if you spilled a glass of water or something like that. Inflow means that fluid will actually flow out of this cube like a faucet. And then outflow is the exact opposite. It will collect the liquid. I'm going to choose inflow, and then I'm going to press play here, and you'll notice that we have our fluid flowing out of our object. Now, since this is the new version of Blender, we didn't have to bake this, which was really nice, but I will show you how that all works. Now, this looks really, really good, but I want to go ahead and show you what geometry looks like. I'm going to select geometry, and we're going to click play, and you'll notice that our cube just falls. Nothing actually flows. So this is a very clear visual example of how geometry is completely different than inflow. Now, this may be confusing at first since it's the new version of Blender, but if we click on our liquid right here, you can see it's kind of highlighted in orange. This is actually our domain. And the reason this makes sense is because if we scroll down on our domain settings on the right, you'll see this cache option like we talked about before. Well, we're going to need to switch up a few different areas in here. Where it says type replay, we're actually going to switch that to all. And you'll see that that snaps our cube back into its own domain. And the reason it does this is because now Blender has no idea what this simulation is going to look like until we actually render it out and we bake it. Okay, so right here for the end frame, I'm just going to choose 100. Now, something that's really important to note is this little tiny cube right here in the corner. This isn't just for visual purposes. This is actually a representation of the size of our particles. If we scroll all the way up within our domain, you'll see that right under domain type liquid, it says resolution divisions. This number is basically going to reflect the size of that cube. You can see that as I lower the number, you can see 24 is the lowest we can go. As I lower and raise that number, that cube gets smaller or bigger. I'll try something like 50, and you can see that that cube gets nice and small. That's the size of our particle. The smaller that that particle is, the more accurate and the more realistic this simulation will look. All right. Now I'm going to scroll all the way down. I'm going to collapse a couple of these menus because we're really not going to go over too many of them. And I'm going to go ahead and click Bake All. And now Blender is going to go through on our timeline and it's going to try to calculate what this simulation is going to look like. You can see it takes a little bit longer than most physics simulations, and our resolution is set to 50, which is actually quite low. But let's go ahead and see what our result looks like as soon as this is done. And now it is done. Let's go ahead and back this up. Let's go ahead and press play. And there you go. Now, it's easy to see, if I get out of X-ray mode here, what this actually looks like. We have our fluid flowing very nicely, and it just drops out of this cube. Now, if you don't want this cube to be here, you can hide it, because as soon as you bake, that cube becomes part of the domain. That looks really good. Now, you can see we have our fluid flowing around, sloshing around. Notice how it sort of takes shape of the domain. Our fluid simulation cannot leave the domain. Remember how our domain was a cube when we started out? The fluid simulation cannot leave that domain. Everything within the domain will be calculated. But again, this is going to hit the walls of those domains because that's where it exists. All right, you can see it gets crushed on the floor here, and then it spreads out like a liquid, and then it kind of sloshes around. This looks really good. Let's go over a couple more examples of what we can do with fluid simulations.